Now, in last period, we have seen the three-dimensional geometry. Some points we have clear, and we have seen the important theorem, the relation between direction cosines of the line. We have seen the theorem, relation between direction cosine of the line, and this is L square plus m square plus n square is equal to 1. That important theorem we have seen in last period. Now using this theorem, we have to solve some important examples which may be asked in our examinations. So which are that type of examples? So we can see first how many and what types of examples are be asked in examination. Now take first example first. I will write first here. Example first. A line makes an angle. A line makes an angle. A line and makes an angle. Measure 45 degree and 60 degree with positive direction of y and z axis, respectively. Find the angle made by the line. Find the angle made by the line with x-axis. So that is our important example which depends upon our theorem. So which is what that theorem we tells. So first, a line makes an angle measure 45 degree 60 degree with positive direction of y and z axis. That is, it is line makes angle 45 degree with y axis and 60 degree with z axis. Then find the angle made by the line with x axis. Means here we have to find the angle, the line which made by the x axis. So in this theorem, in this example, we have to use that theorem, L square plus m square plus n square is equal to 1. So it is very important example. So solution first, let line makes an angle 45 degree 60 degree with y and z axis. Now let we have the line makes an angle, that is alpha is not here, alpha we have to find here. Now that beta is here given, that is 45 degree, and gamma is equal to 60 degree. That we have to given in this example. Means alpha is not given here. Alpha we have to find which makes angle with x-axis. That is beta is equal to 45 degree, gamma is equal to 60 degree. Now therefore we have direction cosine of lines are, that is L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. So that is L is equal to cos alpha as it is, because alpha we have to find. M is equal to cos 45 degree, and N is equal to cos, that is 60 degree. So we have the relation between direction cosines of the line. What is it? That is L square plus M square plus N square is equal to 1. Just we have proved that theorem. So we can put the values of that L, M, N in that relation, and we get the angle which makes the line with x-axis. So what will be this? L square means cos square alpha, M square, that is cos square 40 degree, N square, that is cos square 60 degree, is equal to 1. That is cos square alpha as it is, because we have to find that value. Cos 45 degree, that is 1 by under root 2, and that is square bracket square. That is cos 60, that is 1 by 2 bracket square is equal to 1. So this becomes cos square alpha is equal to 1 by 2 plus 1 by 4 is equal to 1. So next it be so cos square alpha plus take LCM 4, 2, that is 2 plus 4 means 1 is equal to 1. Therefore cos square alpha plus 3 by 4 is equal to 1. Therefore cos square alpha is equal to 1 minus 3 by 4, and last this be cos square alpha is equal to 4 minus 3 divided by 4. So cos square alpha is equal to 1 by 4, and cancelling the square, cos alpha is equal to 1 by 2, and that is, what is the value of cos alpha? 1 by 2. So we have the alpha is equal to 60 degree. So that is our required answer. So now last we can write here, therefore alpha makes an angle, alpha makes an angle 60 degree with x-axis, So it is important to find, if we given two angles, then we can find third angle. So it is important to, if we know two angles, then we can find any third angle, so that from that relation we can find any third angle if we have given two angles. Which theorem? L square plus M square plus N square is equal to 1. So just we can solve as like in our examination, board examination, we can write as it is, but in JE or in CET, in short we can take it. Now we will see next example for short how to in CET or JE. Now take first example. Second example is a line makes an angle line makes an angle 60 degree and 30 degree with x and y axis respectively. Then find the angle which makes with z axis, z axis. Just like similar example, now here a line makes angle 60 degree and 30 degree with x and y axis respectively, and then we have to find what will be the angle of z axis. It is very simple. Now in short we can solve like that. Solution for CET or for G, how it can be solved shortly we can see here first. Now here let cos alpha, now here alpha is equal to 60, beta is equal to 30 degree, because it x-axis it makes alpha angle x-axis, beta makes angle y-axis, and we have to find the gamma what will be in z-axis. So here L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. So therefore we have L square plus M square plus N square is equal to 1. So what will be here next? So that is cos square alpha, M cos square beta, and that is cos square gamma is equal to 1. Now cos square 60, that is cos square 30 degree, that is cos square gamma is equal to 1. Now we know the values of cos 60 degree and cos 30 degree, that is cos 60 degree 1 by 2 bracket square, cos 30 degree that is under root 3 by 2 bracket square, plus cos square gamma is equal to 1. So this become 1 by 4, this become 3 by 4 plus cos square gamma is equal to 1. So this 4 divided by 4 plus cos square gamma is equal to 1. So that is 1 plus cos square gamma is equal to 1. And now the last step is that cos square gamma is equal to 1 minus 1, 0. So cos gamma is equal to 0. So what is the value of cos 0? Cos 0 means that is gamma is equal to pi by 2 means 90 degree. Gamma is equal to pi by 2 means 90 degree. Means the line makes angle 90 degree with z-axis, that is we have to find here gamma. So all these types of examples we can find if we have given two angles using that theorem, which L square plus M square plus N square is equal to 1. So many types of examples we can solve for that. Now we will see next important definition, direction ratio. Now we see next one more definition, which name is direction ratio. So it is, we can write also as direction ratio. In short, we write here a direction ratio. Before this direction ratio, we have completed three definitions first. I will revise it. First, directed angle, direction cosine, and that is last direction ratio. So, what is the direction ratio? We know the L, M, N. What are they? What are these? These are the direction cosines of the lines. We know all this. Direction cosines of the line. Direction cosines of the line. Okay. Then any number, I said that any number which are proportional to that direction cosines are called direction ratio. Now, if L, M, N are direction cosines of the line, then any numbers which are proportional to L, M, N, then that number are called as direction ratio of that line. So here word is that proportional to, that is like that L divided by, similarly A divided by L, M B divided by N, C divided by N is equal to K. Means A proportional to L, B proportional to M, and C proportional to N, and this is the constant ratio. Then that A, B, C are called as direction ratio of that line. A, B, C are called direction ratio of that line. We can write here A divided by L is equal to B divided by M is equal to C divided by N is equal to K. We can also write it as L divided by A, M divided by B, and N divided by C is equal to K. Then that ratio is proportional to a number is called as direction ratio of line. And what are direction ratios? A, B, C are the direction ratios of the line. For example, suppose 1 by under root 3 are direction cosines of the line. Direction cosines of the line. So therefore, minus 1, 1 and minus 1 and 2, minus 2, 2, minus 2. That 2 are also direction ratio of that line because it is in proportional. It is in proportional. Means from this we can say that direction cosines are only one, that is unique, but direction cosines may be different or may be infinite. But line has only one, that is unique direction cosine, but direction ratios may be different and may be different. Okay, this is the main difference of direction ratio. Means L, M, N are direction cosine of the line. Then a number which are proportional to L, M, N, that is like that A divided by L, M, B divided by M, C divided by N is equal to K. then that ABC are called as direction ratios of the line. Now, from this we see the remarks. We see the remarks. The first remarks is that a line has remarks. A line has infinitely mean direction ratios. A line has infinitely many direction ratios, but unique direction cosines. This is very important. But unit direction cosine means lines has only one, that is unit direction cosine, but infinite direction ratios. It may be like that as 1, it is 1 minus 1 1, or it is like that 1 minus 1 1. It is also minus 1 1 minus 1, or 1 minus 1 1. That all are direction ratios of that line. Now second remark is that if you find the direction ratios of the line, if the points P x1 y1 z1 and Q x2 y2 z2, then direction ratios are, that is A is equal to first x2 minus x1, comma B is equal to x2 minus y2 minus y2 minus y1, and C is equal to z2 minus z1. If we have 2 points on the line, that is P and Q, that's coordinates are x1 y1 z1, x2 y2 z2, then we can find direction ratio of that line. That is A means x2 minus x1, that is B means y2 minus y1, and that is C means z2 minus z1. There are the 2 important remarks of direction ratio. With this we can see some more examples for direction ratio. It is very important to us. Now we will see first example